2. Okay, chalo we start now. Now we had studied factors affecting resistance, right? We have studied factors affecting resistance. The first factor which affects resistance is its length. Okay, how is the length? How is the length related with the resistance? Can anybody say? How is the length related with the resistance? We know that, we know that the resistance is directly proportional to the length. Greater the length, greater is the resistance. Okay, double the length, then the resistance becomes double. The current used to become half. Okay, on the other hand, we saw that the resistance is inversely proportional to the area of cross section, right? Which means if I double the area of cross section, then the resistance became half. All of you remember this? In the previous class we did it, right? Now the next thing which we discussed was the dependence of resistance on the nature of the material or the conductor. Okay, and we are very nice. Length is greater the length, greater resistance, Priya says, very nice. Okay, so then we understood something known as resistivity, which we represent with a rho, right? Now resistivity, what is resistivity? Can somebody tell me what is resistivity? Okay, now your answer can come. In the meantime, I'm not doing resistivity. Okay, your answer will come, then we'll start discussing. In the meantime, I go to temperature. Okay, we had discussed that if the temperature rises, if there is a rise in temperature, then what happens? Then the resistance also increases, which means with the rise in temperature, the ease with which current flows decreases. The current, very nice. Nigda Siddhant say resistivity is the ability to resist the current given by a material. No, I'll not take it. Okay, Kushagra says it is the property of a conductor that opposes the flow of current. These are incomplete. Mishti has given us the correct answer. Mishti retracted it. That was the right answer, Mishti. Mishti gave us the right answer. Okay, what is resistivity? It is the resistance offered by the material of unit length, okay, and unit area of cross section, which means if I take it to be a square conductor, okay, then its dimensions are 1 meter, okay, by 1 meter. So 1 meter into 1 meter, its area of cross section becomes 1 meter square. And again, if I take its length, okay, then again it is 1 meter. Got it? Which means it becomes a cube. It becomes a cube of 1 meter. So if I place a cube, okay, of the material, and whatever resistance it is offering to the flow of current, okay, that is called the resistivity of the material. Okay, so Mishti gives us the right thing. What is resistivity? Electrical resistivity is the electrical resistance. See, we had done this, okay? We have studied that resistance is equal to rho L upon A, right? If I cross multiply, then it becomes rho is equal to R into A by L. Got it? And if I say that the area of cross section, if I say that the area of cross section is 1 meter square, okay, and if I say that the length is 1 meter, then my rho becomes equal to R. Okay, in this case rho is equal to R. Got it? So what is resistivity? Resistivity is the resistance offered by a conductor whose area of cross section is 1 meter square, and whose length is 1 meter. Right? I'm sure all of you have understood now. Now next time when I ask, I'm sure all of you will give me the correct response. Okay, so I will move forward. Just a minute, let it come on the screen. Now we go to combinations of resistors. Okay, if you look at the panel of your computer, a panel of your computer, okay, the motherboard or your TV, okay, then you will see many small things which look somewhat like this. Okay, you see small things which are cylindrical like this. Okay, and then there is wire sticking out from both the sides. Okay, and then on this you have colors, you have different colors. Okay, you have different colors bands like this. Okay, you've got different color bands like this. Okay, so what are these? These are known as resistors. Okay, these are known as resistors. Now what is the need of putting these resistors? Okay, now you know that my supply to the device is fixed. Okay, now I have a 220 volt supply to my house, which means the same supply goes to each and every equipment of the motherboard of the computer. Okay, but some need greater current and some need lesser current. Okay, so how do I manage the current which is going into them? So there we use a combination of resistors. Okay, there we use a combination of resistors, and now if I put more resistors, the current going will be less, right? The current which goes will be less. On the other hand, if I use if I don't use any resistor, then whatever current was coming, the entire current will go, because the supply is fixed. The potential difference is 220 volts, right? And if the resistors are put, then the amount of current flowing into that particular equipment can be reduced. Okay, now resistors can be combined in two ways. Okay, resistors can be combined in two ways. The first one is series, in which the resistance are joined end to end. Okay, you can see this is 1, this is 2, this is 3. So I have got 3 resistors. This is R1, this is R2, and this is R3, and now they are connected in series. When I join them end to end, then they are known as to be connected in series. Okay, on the other hand, if I join them in such a way that all are getting their supply from the same point, which means if the potential difference across their ends is same like this, now all of them, suppose this is a boy, so all the right hands are joining together and all the left hands are joining on, whereas in this the right was holding the left, right was holding the left. Okay, so when one after another, then it is series, whereas if all are joined to the same point, okay, then they become in parallel. Got it? And we will study these in detail. This is parallel connection and this is series connection. Everybody understood this much? Now resistors in C, we are going to do an activity. Okay, in this activity, what do we do? Let me write the first few steps and then I bring you back. Okay, in this activity I take 3 resistors. Okay, this is 1, this is 2, and this is 3. So I take 3 resistors and I connect them in series. Okay, now I connect them with a battery. So I bring it and I connect it to a battery. I have 1 cell, 2 cell, okay, 3 cells. I have connected them to a battery. Next, what I do, I connect an ammeter. Okay, I connect an ammeter. So I connect an ammeter over here. Okay, this is negative, this is positive, this is the negative of the ammeter, positive of the ammeter. Okay, and then what do? I connect a plug-in key. Okay, so the key is closed. Okay, and I connect it to this. Got it? Now this is the arrangement we have done, and now we note the reading. I close the plugin key, okay, and I note the reading. Now this is serial number and this is my reading I. Okay, so I note the first reading, and suppose my reading, I give you the, this is 2 ohms, this is 4 ohms, and this is 6 ohms. Okay, I've got 3 resistors of different varying resistances. I've connected them to a battery, okay, and I plug in the key, and suppose that the ammeter reading shows, suppose it shows me 0.5 amperes. Okay, so that's my first reading. This was the arrangement. So now this one, the first reading which I take, I get 0.5 amperes. Okay, what do I do next? Next, I change the position. Okay, I pick up, I remove this ammeter from here. Okay, I remove this ammeter from here and I place it somewhere else. Okay, I join this wire, and now I place my ammeter after the first resistance. Got it? And I continue this the same way. I have the battery, okay, I have the plug-in key, and I have the other resistances. Okay, I have the other resistances. That completes. So I plug it in and I take my second reading. Okay, my first reading was 0.5 amperes, and now I take the second reading. Will the reading be same? Will it be different? Will the reading be same? Will it be different? Okay, no, I don't get any response, and there's a delay, I suppose. Don't worry. So my second reading, when I take, it is again 0.5 amperes. Okay, it is again 0.5 amperes, which means that there is no change in the current. I change the position. Okay, I change the position. Just a minute. I change the position and I place my ammeter over here now. Okay, I connect this, and this is my third reading. I take the third reading, and still I get the same reading. Got it? I repeat it the same way. Just a minute. Now I repeat this the same way. This time I have placed my ammeter over here. Position different. Previously it was between the battery and the plug-in. This time I placed it here, and I get the same reading. Okay, so from this activity, what do you learn? It's not different. I get the same reading, beta. Anirudh, Ankush, Kushagra, Saurabh, Aryan Shaw. I don't get, Anushka, I don't get a different reading. I get the same reading. I get the same reading, and it is 0.5 ampere each time. Okay, there is no variation in the current. Okay, so from this activity, what have I learned? No, Anushka, it's the same. No, Pushpendra, I don't get a different reading. I get the same reading. Okay, so from this activity, we have learned that the current I flowing in a circuit in series, okay, that the current I flowing in a circuit in series is same. It is same. Okay, it is the same for the entire circuit. Okay, whatever current is flowing in the circuit, that same amount of current is flowing through every resistor. I hope all of you have understood. This all activity was to drill in the fact, okay, this entire activity was to drill in the fact that in series the current flowing is same. Everybody understood? This entire activity was to drill in the fact that in series the current flowing in the circuit is same. It is not different. Aryan Shaw, Anushka, Pushpendra, it's not different. Okay, we did this activity just to understand that the current flowing through different resistors which are connected in series is the same in series. Okay, everybody understood? Very nice, Anushka, Kushagra. So I move forward now. Okay, let me erase all this and then we move forward. So through this activity, we get to understand that the current flowing in the different resistors which are connected in series will always be same. Very nice, Saurabh Shukla, if you have understood. Ankush Gupta, good if you have understood. Okay, now I take you to one more activity. Okay, now what do? It is the similar activity, okay, but I do a different thing. Okay, this time what do? Now I take the same resistors. Okay, I have 3 resistors. Okay, 1, 2, 3. Got it? I have got the 3 resistors and I again connect them with a battery. I connect a plug-in key. Okay, and I connect a ammeter. Okay, now this is the positive, this is the negative, which means this is negative and this one is positive. Okay, and now what do is I connect a voltmeter. You all know that a voltmeter should always be connected in parallel. Got it? So I connect a voltmeter to find out that what is the potential difference across the two ends. Okay, now this is X and this is Y. Okay, this is Y. So I have connected a voltmeter across the ends XY of the series combination. Got it? Now what do I note? Now my first reading, got it? My first reading, the current was 0.5 amperes. Okay, now here I take the potential difference reading. Okay, so my first reading of the potential difference, okay, across the whole circuit. Okay, if I am connecting it over here, I can straight away connect it to the battery also. Okay, and suppose my reading comes out to be 6 volt. Okay, so when I connect it, my ammeter is still showing the same reading. Okay, I connect it over here and my first reading comes out to be 6 volts. Okay, now what do I do next? I connect it to the first resistor only. Got it? I connect it to the first resistor. This is R1, this is R2 and this is R3. Got it? So I connect it only to the first resistor and I note my reading. Okay, so the second reading is giving me the potential difference across the resistor R1. Got it? And I see that it comes out to be 1.8 volts, suppose. Okay, we are just approximating. Okay, so this time the reading is different. Okay, I change the position of the voltmeter and the reading has changed. Okay, I do the same thing. Now I take my third reading by changing the position. What change do I make this time? I this time remove it from here. Okay, and I connect it over here, which means now this time only across resistor 2. So what is the potential difference across resistor 2? I get to see that it is 2.4 volts. Suppose it is 2.4 volts. Okay, and then what I do is, for taking my fourth reading, so I am seeing that every time I am changing the position of the voltmeter, the reading is changing. Got it? So this time what I do is I now connect it across the third resistor. Okay, I connect it across the third resistor. I remove it from here. I remove the whole thing. Okay, and I bring it over the third resistor. Now I connect my voltmeter in parallel to the third resistor. Okay, across the ends of the third resistor, and this time reading across R2. Okay, this is giving me the potential difference. Okay, across which resistor? That Now my reading across R2 this time comes out to be, how much does it come out? We could have made it different slightly. Wait, I'll change, okay? I'll change one so that you know that they have to be different. I'll change this. Okay. Now we suppose that in this case it was 1.6 and in this case it is 2.4. So in this case it is just 6 volts, hai na? 4, 3, 7. It is 2 volts. In this case it is 2 volts. Okay. So you see that the potential difference across each of the 3 resistors is different. Now what do you note? What analysis are you doing? What fact do you get to understand from this? Let me have a look. क्या समझ में आया अब आपको इस एक्टिविटी को देख के? क्या समझ में आ रहा है? Okay, now Mishti wants to know how was the first reading noted. The first was when I put it across the battery, Mishti. Okay, मेरी बैटरी, which means ये जो मेरी बैटरी है इसका पोटेंशियल डिफरेंस 6 वोल्ट है, तो मैंने बैटरी के दोनों एंड्स पे लगाया तो मुझे 6 वोल्ट्स आया, ठीक है. और बाद में मैंने एक एक रेजिस्टर के दोनों एंड्स पे लगाया तो मुझे अलग अलग रीडिंग आई. एक में 1.6 आई, एक में 2.4 आई, एक में 2 आई. Very nice. Now Priya has given us the answer. Okay, Priya says that very nice, correct answer. Okay, which means that the potential difference across the whole circuit, okay, is equal to the potential difference across each of the resistors. Okay, V is equal to V1 plus V2 plus V3. Okay, this is V1, this is V2, this is V3. Let me change the color. Okay, so this is V1, this is V2, this is V3, and this is V. Okay, this is V. So you can see that V is equal to V1 plus V2 plus V3. Okay, which means that all the resistors have different potential difference across its end. Okay, and when you add them up, it comes out to be equal to the total potential difference across the whole of the system. Everybody understood? The first reading, beta, the first reading, you simply attach the voltmeter over here. Okay, I attach it to the ends of the battery. This is the voltmeter and I attach it to the ends of the battery. You can connect it over here, or simply like I had done, I had connected it across the whole thing. Okay, I had connected across the whole resistor system. You can do it either way. Okay, but we say that we should connect it across the 2 terminals of the battery to know what is the potential difference in the whole circuit. Everybody understood? Give me a yes so that I can proceed. How much time is left? We are left with 10 minutes. Be quick, otherwise we'll not be able to finish this. So we now measure the potential difference across. Here the children were asking me, okay, फर्स्ट रीडिंग कैसे ली, फर्स्ट रीडिंग कैसे ली? तो हमने बैटरी के दोनों टर्मिनल्स के अक्रॉस लगाया और रीडिंग ले ली. ओके, नाउ वी रिमूव द वोल्टमीटर एंड वी कनेक्टेड अक्रॉस द एंड्स XP of the first resistor. We get the first reading. Okay, V1. We repeat similarly by connecting it. Okay, we are doing it mathematically. We're going there. Okay, now we measure the potential difference across the other 2 resistors separately, and we say that the values are V2 and V3. Got it? So we get to see, on deducing the relationship, we find that V is equal to V1 plus V2 plus V3. Understood this much? Okay, now we use Ohm's law. Okay, now we use Ohm's law and we say that we have understood that the current across each one is same, right? We have understood that the current across each one is same, and if we say that suppose the resultant resistance we denote by RS. Okay, RS is the resultant resistance, then using Ohm's law, okay, then using Ohm's law, what do we get? Using Ohm's law we get that V is equal to I RS. Okay, this is our second equation. Got it? We know that the current will be the same. Okay, similarly Similarly, I get V1 is equal to I R1, right? And I get V2 is equal to I R2, and I get V3 is equal to I R3. Everybody understood this much? Okay, because the current will remain the same, so you can see that I is the same in each case. I know that the resistances are different, so V1 becomes I R1, V2 becomes I R2, and V3 becomes I R3. Okay, now I put these values in the first equation. Okay, I put these values in the first equation, and what do I get? I'll erase this and take you there. Okay, I put these values. Okay, we get V is equal to IRS, right? That's my second equation. And similarly, on applying Ohm's law to the three resistors, I get V1 is equal to IR1, I get V2 is equal to IR2, and I get V3 is equal to IR3. Okay, so I put these values. Okay, so from equation 1, 2, 3a, 3b, and 3c. Okay, I had V. Okay, V is equal to V1 plus V2 plus V3. Got it? So I put the values and I get IRS is equal to IR1 plus IR2 plus IR3. I bring out the I common. Okay, so I cancels and I get. Okay, so everybody understood? So we get that RS is equal to R1 plus R2 plus R3. Snigdha Siddhant understood the mathematical derivation. How do we start? We start by V is equal to V1 plus V2 plus V3, right? Then we know that I is same in all. So we go to Ohm's law and V is equal to IRS, V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. Okay, then I replace these values in my first equation and I get IRS is equal to IR1 plus IR2 plus IR3. I on both the sides I take common and cancel it. So I get RS is equal to R1 plus R2 plus R3, which concludes that when we put several resistors in series, then the resultant resistance of the combination equals to the sum of individual resistances. Right? Everybody understood? So if you have understood, you have to give an answer to this question. Okay, now I have eight resistors. I have 8 resistors, okay, which are joined in series, okay, and each resistor is of 6 ohms. What is the resultant resistance? What is the resultant resistance? Please tell me quickly. So the question is that there are 8 resistors which are connected in series and each resistor is of 6 ohm. What is my resultant resistance? And Anirudh says 48. Very nice, Anirudh. It's 48 is the correct answer. Smart kid. Okay. So how do we do it? Okay, we could have simply added it up, which means 8 plus 8 plus 8 6 times. But what do we do? Okay, when they are same, then RS is equal to NR. Okay, in this case N is 8, okay, and R is 6 ohms, so it becomes 48 ohms. Very nice. 48 ohms. Priya also gives, Kushagra also gives, Siddhant and Snigdha also give, Janvi also gives, Anushka also gives. So Anushka understood. Anushka had been asking me since many days and I was not giving answer to her queries. When will you teach it? Very nice. Anirudh says R1 plus R2 plus R8. Correct. Okay, very nice. So we move forward. Okay. So to better understand, we will do a numerical. Okay. Now we have understood this. When 2 or more resistors are connected end to end consecutively, they are said to be connected in series. Kushagra, you got your answer, right? When they are connected end to end, they are said to be connected in series. Okay, and according to law of combination of resistance, the combined resistance of any number of resistance connected in series is equal to the sum of the individual resistances, right? Now one thing which in fact a few things which you keep in mind is that, number one, if they are in series, then the current flowing will be same. The current flowing through each resistance will be same. This you have to understand. Okay, the second thing which you have to remember is that the potential difference across each resistor is different. Across each resistor is different, right? Everybody understood this much? And the third and final thing which you need to remember is that I use a series combination when I want to increase the resistance, because the resultant resistance is greater than the greatest resistant. Okay, now suppose there were 3 resistances, 2 ohms, 4 ohms and 10 ohms, then my resultant will be greater than the greatest. That means it will be greater than the 10 ohm also. Obviously when you are adding up, it will become greater than the biggest one also. Okay, so these 3 things you need to remember, that the current is same in all the resistors across the whole circuit. Number 2, the potential difference across the different resistors is different and it adds up to be the whole potential difference of the circuit. And finally, the resultant resistance is greater than the greatest resistance. Okay, very nice. Kushagra says understood. Have you given a like there also, Kushagra? Okay, nice. Chalo. Now we do a question. How much time we have? Oops, we don't have time. Time up. Time up. Okay, should I do it quickly? No, ma'am says no, I've got a class, please move away. Chalo, we'll do it in the next class. I am sure all of you must have understood combination of resistors in series. In the next class we do parallel in a similar way, and then we go to solving some questions in which we have a combination of series, some in series, some in parallel, or a mix of both. Okay, and many children have asked me how to solve such questions, how to go about them. So we will spend quite some time. We'll spend at least 2-3 classes there, because you get good number of questions also from this section, and the ones who will be taking science, they will get questions from this in your IIT entrance exams also. You'll be getting you have electricity in class 12 also. So we'll spend some time over here, right? Thank you very much all of you. That's all for the day. It was wonderful talking to you people. How did you like this class? Give me a feedback. Okay, thank you very much. Signing off. Bye bye. See you.